All right, we're back with more DiSco mimo. Thanks for sticking around. Thanks for watching the series. If you're watching on YouTube, thanks for following along. Thanks for the subs, follows. You know what to do. Pretty good progress last time. If you're on YouTube and you didn't see the last episode, you should really watch that. Like, we finally managed to crack everything. Not only did we make it work, we made it work in two different ways. One of them exactly like the paper says, but that's completely different from what the legacy code does. So we got both variants to work. I'm kind of starting to remember why I did the code that way, why I deviated from the paper, which is pretty bad practice. I won't lie, that was bad for me to do, but the paper as it should, it really does work. So we got the training, we got the inference, PyTorch signal processing done, data generation done a few episodes ago. That was also a big hurdle. The data was wrong. We had to fix it just by reading MATLAB docs. Loss function performance metrics. We validated the loss goes down. Inverse problems we haven't done, but they're there. We have support for modern architectures. I want to go back to some of more of the blue stuff now. Okay, so to wrap up, because again, in the next episodes, and if you're watching on stream tomorrow, I actually want to stop coding and just write a paper about all the efforts we did, which is going to be really interesting. And I will submit that to a real conference. So it will be a real academic paper. It's a bit of a meta paper. But in order to do that, I want to finish typing and more advanced configuration, including maybe some clean logging. I don't know if we have time. So let's get right into it because we don't have too much time. I've been streaming for like 5,000 million hours. So OmegaConf structured configs. We've seen this before. If you've watched my DSPy series, you kind of know what this is. So OmegaConf structured configs Hydra. Okay, so I'm going to add two packages, OmegaConf and Hydra with structured configs. This is an advanced tutorial, are available here. Okay, so we need to see the defaults. Gotta remember what to do here. Blah blah for OmegaConf missing. Okay, all right. So now let's see. Not to mention we did a bunch of UV stuff in the past episodes. Just check it out. There's a lot of stuff. So we're on a synchronized main. Let me remove some of this, I don't know, data wrong. I don't want to see that. That's gone. Samples will be our golden model. CPLX can go to yes to all. Models instance norm can go to yes to all. Okay, so paper sample, sampling log repro. We should keep these for now. That may be useful for writing the paper. Models. This will be our golden thing. As long as we change sampling, we need this to work. Okay, so UV sync, group, torch, UV sync, UV lock. No surprises here. Let's check out a new branch, -b, OmegaConf. Okay, so let's clean up all these configs because we want you. So what is the idea? I'll crash course it. We want users to be able to change these from the command line, right? So let's say how do I train a model? Let me rename this. Something else I like to do is I rename the folder models golden. Once I know this works, I'm gonna keep this. So now let's say I want to run training. So I do group torch -m mimo train, and it starts training. What if I want to change the learning rate? I want to do 003. I can't, I have to edit the code, okay? So then OmegaConf and Hydra does that. So UV add, OmegaConf, I forget, oh god damn it, I forgot what Hydra is. How do I install Hydra? Because it's not Hydra, that's the stupid thing. It's Hydra minus core, okay? So UV add OmegaConf and Hydra core. To which group do we want these? To both groups. Be careful here. Both to torch and to Siona. We're gonna need it in both cases, okay? because we want to be able to configure both cases. And it may be that they pull different versions. I don't know. We'll see. Like, for example, in the Siona group, I guess it's pulling Keras for some wild reason. I have no idea what's happening here. Okay, it did pull a ton of stuff. Okay, so now we have our Hydra core. I like to pin these down again. So once I have a version, I'll pin it down. Diffusers torch, H5 pi, blah, blah, blah. Torch Siona, we had to downgrade torch. We know that, unfortunate, but whatever. UV lock. Okay, so we changed dependencies a bit. I am a bit worried about this. I'm a bit worried about what it did to Siona. So let me run data generation, okay? So how do we run data generation? Pretty easy. I just run. See, this is an example case actually. Let's actually integrate OmegaConf right here, because where am I gonna save my data? Right now, I have a folder on disk called data, which, because I'm gonna rename this to data golden, just so I don't lose it. But my point is different though. I don't know what's happening. My computer is fried. Do I have the eek? Okay, I guess Windows takes a long time to rename a folder, sure. Now my point is different. Let's say, so I would really like to be able to configure this save directory and the save tag. I have no idea what's happening with the... Okay, well, this is really weird. So then we're gonna integrate OmegaConf here. So what do I do? Well, I don't know, because I have to read the examples and I have to see the basic Hydra. But it's not that hard. So I just import Hydra and these 3 lines, I believe. Okay. Now, if my mouse would work, that would be awesome. There we go. Nope. There we go. Okay, so I have OmegaConf, config store, and Hydra. Okay. Whoops, import Hydra. So what do I need to do? Well, I believe I need to register this config. Okay. So I believe the syntax is... There we go. So you make your configs. Here's the syntax, right? So CS, and you need a Hydra main decorator. And I believe that is it. Okay, so I need the CS config store instance. I don't think I need a group. I'm just gonna leave it default group. And we're gonna call this CDL underscore config, or I guess CDL, okay? In the config store group. And then we need to decorate our main. Do we need this plot tensor grid thingy? I guess we do. So our main function now becomes decorated with this Hydra thing as a main entry point for this app. Now this is very, very important, because now it takes as input a config name CDL and it outputs a none. And there's a toDict function or something, which I need to convert, which I don't remember. So CFG, but the thing is, I don't need to create this anymore. Okay, so now my main just calls like this, okay, without an argument. This is a fake argument that Hydra does. So we just need to annotate this with none too, so it's nice. Okay. So now I just need to remind myself. Okay, sure. Actually, I'm gonna rename this branch because we gotta go fast. OmegaConf and Pyrite. There we go. I'm gonna do two things in one now. So let me try a breakpoint here. Now what's gonna happen is a miracle because we'll make the save dir missing, okay? Or was it not? I'm sorry, so from OmegaConf import missing. So now what's gonna happen is I can no longer run this app without specifying a save directory, okay, from the command line. So if I try to run, let me rearrange these in order of importance. Order of importance is debatable. Something like this. So now if I just try to run group Siona mimo.cdl, this is gonna crash. Sorry, -m mimo.cdl. I hope it crashes. It did not crash. Despite this being missing. So what am I seeing in CFG? Oh yeah, it's question mark, right? CFG save dir. Okay, so only when I try to access it. Can I not always have an error though? Whoa. What is happening here? So, Omega Hydra raise error on missing mandatory value. Like, what's the point of Hydra? It's only accessing? Oh, for God's sake. The exception is only raised, not during the initial configuration loading process. Well, this is kind of a bummer because... Okay, so anyways, I guess we'll have to live with it. But here's the trickery though. There is a way to configure this to a dictionary and it will raise the error immediately. I'm trying to remember what it is though. So I can do config CFG and I can do CFG equals OmegaConf. What? I'm trying to remember. So, because I can't access the, I can't do dot. Okay, I can do dot. Well, that's it then. Then this thing will crash. Okay, eventually. Because what's gonna happen is something will try to use the save directory. Oh, I guess it's too late. It's trying to use it late. So this is a good clean coding design, okay? So we should make this directory ASAP. There we go. So now the app will crash instantly, right? So let's try to make this file name and directory ASAP. There we go. Okay, so mandatory value missing. But now Hydra allows me to do stuff like save dir. I can just say data Hydra test. I can put it even as a string. So it magically becomes a command line argument, and there it is. The folder was created and now it's generating data, blah, blah. Everything works as expected. Okay, so save location. So now this is what I call, we Hydra-fied this app, okay? And by the way, everything is running, so all the dependencies are good. So we can add PyProject toml uv lock, git commit -m, add deps for OmegaConf and Hydra. And we just need to do this thing 5 more times to Hydra-fy everything. We have to clean up the configs a bit too. Git add src mimo.cdl, git commit -m, Hydra-fy Hydra-fy cdl, mimo.cdl. Good. Now let's also pyrightify this. Let's add pyrite support, which is a whole different beast. If we add, actually, let's not add pyrite support yet. Now, while we're on this file, let's clean it up forever, okay? Because this is a one-off file. We do not want to touch this. Let's add a copyright, for example, right? This is one of the things I can think of. It's kind of dumb, but basic copyright for Python. Python script. Can I find an example? Like, what am I supposed to do with this? Okay, so copyright 2026, because I kind of like having a header to files, okay? There we go. Okay, so we cleaned this up too. Well, you know what? Let's not. Let's add that in a different PR because we're doing clean coding, right? This is not how it's supposed to work. Okay, so let's focus on Hydra config. Now, what else do we need to do? I'm not too happy with the file name convention. So we don't need all this. If I let the user put a save tag, I don't need to put other parameters, okay? So then my file name can just be called, and I just need a directory. So is there any way, can I just give a file? How about this? So save path. Why don't we do it even smarter? Can I just give a save path? And the path needs to be a file. Okay, so I'll do it this way. We'll add a post in it, which does a basic check. Verify that save path is a file. Okay, so if not, actually we don't need comments here. If not, save path dot suffix self arrays value error, save path must be a file. Now, if the user gives a very complicated folder, that's still fine because we're gonna do config save path dot parent. And that's it, all right? So we're gonna create all the parent directories, and we can just save to save path without having two inputs. So this is what we mean by a cleaner config now, okay? So let's try it out now. So let's see, what if I do, now let me check if I did it right, path lib suffix. So I think path lib check if path is syntactically a file. Nah, but I can't check is file because this checks if it exists on disk, and it will not exist on disk. Yeah, I have to do a heuristic. So dot suffix. Oh, and I also need to make sure that it's... So actually there's a, I need to make sure this is an H5. No, this works, right? Yeah, this works everywhere actually. Yeah, H5 files don't need to be terminated H5. All right, good. So I think it's not a method, it's an attribute, okay? So if I don't have a suffix specified, I'll have to raise an error. And this will happen instantly, right? Otherwise, CDL model, these we need to let the user specify these. And these are also fine. These are secondary parameters, but the user can now override them easily. Okay, so I think this is it for this one. It looks pretty clean otherwise. But this is the easy one. So what do we do? So let me try out this file thing. So what do we say? So uv run group Siona -m mimo.cdl save path is stuff to save .h5. So this should create the nested folders. Which I do not see. Okay, interesting. So what is the parent? Because I'm... is it relative to the output? I think so. I think Hydra changes my path, right? Does it? So where does it create this? Hang on, there's one more detail here. Because Hydra automatically creates an output folder, which I don't like. And I think it's creating the stuff to folders. Not really. Where the heck is it then? So what is happening here? What is my save path? And what's with the parent of this? Stuff to. Oh, here it is. Stuff to. Okay. Oh, I'm so stupid. Okay, there we go. So it all worked. And then it'll save it in there. Okay. So, and here's how I can test this now. Because let's say I want to test the app quickly. Well, I can. Because I don't have to wait for... With Hydra, I can just override num samples is 20. Okay, and that's it. Then this should be fast. I should see it instantly. There we go. Stuff to save.h5. Okay, I can also call it save other dot blah blah, as long as it has an extension. I mean, I don't know how Windows complains here, but this should still work. Okay, but if I don't give it a stuff to fail, if I do not give it a suffix, it did not fail. I want this to fail. So what is very confusing? So what the heck is self-safepath.suffix in this case? Oh wait, did I type post init wrong? I think I did. This is not how you do post init. Post init Python, obviously, because I do not know. Oh no, it is right. Whoa, wait. Oh, because I'm not doing the OmegaConf thing. This never triggers. There's one more trickery here. Oh, come on. So how to trigger OmegaConf structured config post init call. But it's not. It's dict config. This is what I want. Convert the dict config. This is what I need to object. I know I was looking for this. So there is a trickery here. So I need to do from OmegaConf import OmegaConf. There is a trickery here. Aha, good. It hit. Very good. Okay, so the error hit. And then if I go to fail.ky, this is a file. There we go. We're done. All right. So this is delete everything. Good. Oh, delete this. Yes. Okay. All right. So git status. What do we have here? Okay. I believe this is cleaned up. I don't think we can clean this up more. We want the user to do everything. Now there is a problem though, because we're gonna have to clean up config and harden. And that's it. We're good. Okay, I really need to learn how to, I don't know what this is. So now we clean this app up, this submodule up. There's not too many more now, right? Next one. The next one is tied to it. It's data, but it is trickier though. We have to think a bit about data now. See, there's a problem here with data because I have a distribution parameter, which is also CDLC. So this is a duplicate now, and I really don't like this. Actually, why is the CDL model? Oh, I see. It only wants a letter here. So now how the heck can we get this? Well, here's the clean Python logic. I should ask for a file. And if that file doesn't exist, I should raise an error and tell the user to run the other command. I don't want to carry these duplicates around here, okay? This is a duplicate. 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 Okay? We gotta think carefully here. What that means though is that I need to store some metadata in the file. Okay? So because when the user loads the file, they should also be able to infer what's in there. and it's really these 4 things. So we need to save these to the file too, okay? So it is a bit trickier, hang on. Where do we save this? Here we go. So we're gonna save more stuff. So we're gonna save create data set. So what do we need? num.rx, num.tx, CDL model, num samples. Actually, num samples we don't need. We can infer that from the, okay? So CDL model data will be cfg.cdl model. Whoops, sorry. Did I mess up the zoom? I believe I did. Oh no, did I mess up the zoom? Yeah. I don't know how I messed up the zoom, but sure. Oh, I know what I did. I messed up my camera. Interesting. Earlier I must have... I can make myself bigger again. Okay. So where were we? So we were about to save more stuff in the file, right? So for example, we're gonna need... And let's try to respect the order in which they appear so that it's the same here. Rx, TX, Rx and TX, Rx and TX. Okay, so num.rx, data, cfg.num.rx and TX. Okay, so this is a big advantage now because in the data app, I don't need anything. I just need the user to tell me exactly the same thing like here. And these are chained together now, okay? So I just need a load path now. Okay, now same thing. Let's OmegaConf this and hydraize it or whatever. So blah 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 missing. What else do I need here? I need a config store. I need a post init which now really checks if this is not a file. Okay, so if not, self load path is file. Okay, load path must be a file written by mimo.cdl. Okay, so now this tells the users you did something wrong. Data config. Okay, and where's our main? We have no main. This will become our main. Okay, this cannot become our main. Watch out here. So this is not a standalone app, is it? It's not, but we can still use a config for it. So we're not gonna hydraize this. We're just gonna OmegaConf it. There's still value in that though, because I can just do yeah, so I don't need the CS then. Okay, so this one's a bit different. This is actually a nice use case because interesting. Oh damn, I messed up my zoom. Because it only needs 3 arguments. Well, this mouse is driving me insane though. So get data, but we still want to put them in a CFG because we don't want... Or is it worth just doing 3 functions here? I think sometimes it's better to think in terms of simplicity too. I'm thinking. Okay, so let's see. So this has to be completely reworked because it just does. Let's keep it like this actually. Okay, so let's keep it like this, and then all we do is we peek into CFG dot load path, and we load data, and we convert it to tensor, and we're done. Okay, that's it. I think this is good. Yeah, this is clean enough, and this will yell if the file doesn't exist, so we don't have to check this. Why do we need undersampling and measurement noise? We forgot to annotate this. So this is a tuple torch tensor and torch tensor. Torch tensor. I think we can ditch OmegaConf here. We don't need it then. Load data is too basic, right? So we're just gonna say, give me a path. And actually we do need the check. So we're gonna keep the check. We'll do it this way, right? So we're gonna yell, if you didn't give me a path, if it's not a file, load path must be a file written by, okay, there we go. So then all we need to do is, we don't need all this. Let's try to simplify as much as we can. We'll see why, because once we get to the main, it's going to require a lot of redesigns. But where am I going to get this metadata that I wrote? Because I'm going to need this everywhere. Interesting. Very interesting. Very, very, very interesting. I'm a bit of a conundrum now. So, okay, I can get the data from a file. This depends on Torch. The problem is these two files are incompatible, and this is a big problem we need to solve now. This is one of the last problems we need to solve, actually. I mean, this is the problem we need to solve config-wise. So... can I remove Torch from data so it works with any, both with Siona and with Torch? Or is there a special way to mark this using UV so that it doesn't pull in all the dependencies? Because if I run in Torch and I cannot import from CDL. That's the problem. And I can't also not import here, which is very annoying. I think the solution is to... it's a tough one. It's a really nasty one too. Come on, we can do this, right? The easiest solution is to split this into a new file called config.py, which doesn't depend on PyTorch and just holds this data class. And then we can do a sub data class here. I want these 3 fields. Okay, here's my problem. I would like these 3 fields to be their own data class. Where do I define that data class? If I define it here, I can't use it here. If I define it here, I can't use it here because data and CDL. But I want it here because I'm going to create it on the spot. Really feels like it should live in CDL, but unfortunately CDL depends on Siona. Still thinking. This one may be worth a question to Gemini. Suppose I have 2 incompatible UV dependency groups, but I want them to share a data class. How can I cleanly, idiomatically do that without moving it to its file? It cannot live in either file because the files can't import from each other. Incompatible depths. The protocol pattern. If you want to avoid the share file, you can have the shape of data class. Nope. Duck typing. Nah. The standard library bridge. So I feel like I have to do a file then. I'm locking myself into a file, all right? Yeah, this is classic dependency hell. Oh, yeah. Or yeah, okay, we'll do a file. I actually don't know how to do this one. It's a nasty one. We'll do a utils.py. And what we'll do is we will import from it in both cases. And the reason where I want to go is I would like a tiny data class, which is really, really tiny, but it is going to matter, like this. Okay, so we'll put data class and we'll call it channel config. Okay, and that's it. It has all these 3. Now, how do we integrate this in CDL? Very simple. Channel is a channel config. And it has a default, it's a field default factory. It's channel config. So from data class, import data class field, okay? And from mimo.utils, import channel config. There we go, okay? So now I have a default channel here. And I just need to access stuff as CFG dot, it's not gonna be dot numrx, it'll be dot channel dot numrx and so on and so forth. So now the advantage is I can import this there we go, CDL model. I think that should well, this too, boom boom boom, channel, a lot of stuff here. Okay, and we'll also save these to the file. All right. And here we can also import from the same thing. So from mimo.utils import channel config. And we can say that config is a channel config. We can actually make it here. So the config is going to be a channel config, which will be F. So what do we need to do? CDL model will be F. CDL model. Num RX will be F. Num RX. F num TX. And I want to return this, okay, because I'm gonna need this on the outside now. Okay, so it's a tuple between the torch tensor and the channel config. I can unpack it on the outside or depend on it. This should be enough now. Convert data to tensor, okay? Yes, I think this is the way to do it, right? It's a tiny file, but it's worth it. We shall see. UV run, pre-commit, run all. All right, so we need to write about solving dependency hell with mimo.utils. Sorry. Okay, so now we're loading. We're saving this to disk here, very important. And when we load the data, we also recreate the config. This is probably the only clean way to do it. And maybe we can save the whole data class, but I don't even want to depend on it actually. I'd rather have raw data and let the user read it however they want. This looks pretty clean. Minus this long line. Yeah, it's pretty clean. Yeah. Did I get the field default factory right? Let me see. We can validate that. Because I can just run UV run group Siona, right? Fail.y. I believe we did get it right. So cfg.channel, yep, it has everything now. And this can also be overridden now, right? So a user can say from the command line, what is it? Channel.cdl model equals A. cfg.channel. There we go. It's overridden and will be saved to file. So this is clean Python. Okay, this is what I want to do. All right, we're kind of getting there, but we still have a long way to go, unfortunately. So now we finished hydrolyzing Hydra-eyes mimo.data. Okay, but even so, we already had to intervene on CDL. Now, we're getting to the harder ones. Losses. Do we need anything in loss? No, losses is pure. Okay, good. Losses were clean. We can cut this comment here. We do not need this. Okay. So let's clean that up, because I actually don't like comments. The code itself should be clean enough. Clean up mimo losses. The code itself should be clean enough so that it always expresses what you want to do. You don't need verbose comments. All right, so we did the easy ones. There's 2 more now. Train and sampling now, and models. But models is also an easy one to clean. We need to OmegaConf models too. Aha, we have a problem with models because we have to do nested OmegaConf, which we'll have to clean up next time. And then the big ones are train and sampling, which there's a lot of copied code, but I think we have learned enough now that we can do it. Okay, so we'll save stuff to files, we'll do it nice. So we'll take a break. Thanks for watching. So next episode, if you're watching on YouTube or after a quick break, we'll keep working our way through these configuration modules, and it's going to be nice. We'll clean them up, and this is probably the final cleanup we're doing, and then we can just turn typing on, fix the errors, and we're done for good. All right, break time.